Alrighty, thank you very much. And apologies to anyone who was hoping to see the cat cam as I was giving the talk, but he moved to the other room. So yeah, I'm Russell Wolf. I'm going to talk about the Kotlin Swift boundary. So I've been doing Kotlin multi-platform stuff for pretty much as long as it was possible to share code between Android and iOS. I work at Touch Lab, where we build Kotlin multi-platform things for clients, and also a Google developer expert for Kotlin. So we're mostly all Android developers here. We know that Kotlin is not just an island in Russia, but it's a programming language. So runs on Android, runs on JVM outside of Android, and of course also has a JavaScript target for web development in the browser or in Node. And it has native targets using LLVM and interoping with C APIs. And the very interesting subset of that, of course, is iOS interop and via Objective-C. And tying all of that together is Kotlin multi-platform, which lets you write common code that can build to any of those targets, and platform-specific code that cannot interop with the APIs of that platform. And what this gives you overall is this nice kind of flexible interop story where you can share the pieces of code that make sense to share while not tying your hands from writing the platform-specific code that you want to create the best native experience for your platform. So I work with Kevin Galligan, who is fond of putting this quote in his slides. Like shared UI is almost always painful. If you look at any of the other cross-platform things, cross-platform frameworks out there, and I won't name any specific names, but shared logic is everything in computing. It's everything we always want to do when we're trying to don't repeat yourself, to make our code concise and efficient. And like, as Android developers, like, we're used to the Java ecosystem, which is the best example of that. Like, Java doesn't do a ton of shared UI, but it backs a ton of, it runs in a ton of different environments as long as they're able to run a JVM. Kotlin just takes that to the next step by being able to run without a JVM or without a VM as well. And I have for a long time believed that mobile is the real killer app for multi-platform. So we have all these different platforms that Kotlin can build to, but Android and iOS are really the two that are trying to do the exact same thing. Like, if you're a user or maybe a product manager, like, you don't care that under the hood these things are running on different frameworks and talking to different APIs. You care that they're trying to do the same thing. And using Kotlin multi-platform, you can make them actually run the same code to do the same thing. But don't just take that from me. JetBrains has been putting a lot of effort into the Kotlin multi-platform mobile brand. So what this means is it's a bit of a kind of marketing term, kind of collecting the mobile specific use cases of Kotlin multi-platform, but it's also a really strong signifier of how invested JetBrains is in this ecosystem, in this use case. They have like a dedicated team of developers and testers and product people, et cetera, that are all focused just on the mobile use case and stabilizing that and making it work, which means it's a really nice time to be jumping in and trying to use it. So let's talk a little bit about what that all looks like in practice. So I like to kind of describe shared Kotlin as this Venn diagram, where on the left side you have the Android code that you're used to writing as an Android developer. And the middle is this subset that doesn't know anything about Android, but does know about Kotlin things, knows about the standard library, knows about third-party libraries that have been built to be dependent only on the common platform. And that means that it can also be built to iOS. And this is not just kind of a metaphor, but it's also like what the compiler is doing under the hood. It builds the Android app by putting these two pieces together, and it builds the iOS app by putting these two pieces together. So it's a nice kind of mental model for what is going on here. And those pieces can each be as big or as small as they need to be for your use case. So what does some of that look like in code? So common code is just Kotlin. It's Kotlin that doesn't talk to any platform-specific APIs, but it still can build classes, use the collections API, run a print line function, create a list. But when that's not enough, you can go down into platform-specific code. And multi-platform adds these two new keywords to the language, expect and actual. So you can expect a value in your common code and give it a different implementation depending on the platform, so that your common code is able to trigger that from the platforms. And that's useful in some situations. Sometimes you want a little bit more flexibility. So because expect actual needs to be exactly one-to-one, sometimes it can be convenient to, sometimes it can be convenient, maybe for different use cases or different parts of your app, you want to have different definitions of this expect declaration. And in that case, you can use an interface the same way you would in your typical single platform code. So it might have like this logger interface that has an Android implementation, an iOS implementation. And what's really nice here is it doesn't even have to be implemented in Kotlin. So you can implement your Kotlin interfaces in Swift, and you can have multiple implementations. Maybe you want to have a test one, et cetera, et cetera. And you also do the same thing with just like a shared function call that you pass a parameter to, like a callback. And each of your platforms can do a different thing with it. And again, that can happen from Kotlin or from Swift. So how about what this looks like kind of architecturally? So again, we have kind of our common code in the center. So this is essentially our the Venn diagram that we had earlier. On the left, it builds an Android AR library the same way that it does in your typical Android code. On the right, it builds an iOS framework, which is the iOS library dependency or library format. And then that basically just behaves as a library that each of your applications calls into. And they can then also call into whatever other platform APIs they want to, or other platform libraries they want to. And no other parts of the app need to worry about the fact that this one piece is where the shared code is, because elsewhere it just looks like one more library. So that's where you get the nice and flexible interop. But what I want to focus on for the purpose of this talk is kind of this corner of that diagram. So what it looks like when we go from our common Kotlin code up to the iOS app and the little things that can happen along the way. So let's look at some examples of what it looks like to go from Kotlin to Swift. And an important thing to keep in mind through all of that is we're doing it through the boundary of Objective-C. So Kotlin doesn't actually know anything about Swift itself. It interops with Objective-C, and then Objective-C knows how to talk to Swift. So suppose we have this person class. So a simple class has a property in it, constructor property in it called name. And don't worry about all the little details of this, but this is what it generates in terms of an Objective-C header that the iOS code is able to call into. So it's there's a shared person interface, which is the equivalent of the person class. It inherits from a shared base, which is where a bunch of the Kotlin magic lives. It has a init with name, which is the equivalent of the Kotlin constructor, and it has a name property, which is the equivalent of the Kotlin property. And then there's a couple of annotations in there that basically make the calling from Swift a little cleaner than what it looks like from Objective-C. So your Swift code, you can create a person in a way that looks fairly familiar if you're used to Swift or Kotlin, and you can read the property out of that person. So okay, that's enough staring at ugly Objective-C code. Let's just look at the Kotlin and Swift. So maybe we want to add another property to this class. We want to be able to have a nickname, so we can add that to the definition in Kotlin, pass it in iOS. But what if not everybody has a nickname, right? So maybe I don't want to pass one. So let's add this, make this nickname field nullable, give it a default value of null so that the caller doesn't have to worry about it. But when you try to do this in Swift, you get an error. And what's happening is this guy again. So because we're going through this Objective-C layer, Kotlin knows about default parameters and Swift knows about default parameters, but Objective-C does not. And so the like that default equals null, this equals null right here is not translated from Swift to Kotlin. And so we're forced either to pass null ourselves manually, or we can change our person definition, give it a secondary constructor by hand, so that Swift doesn't need to worry about that. And that's a nice example of the sort of thing that comes up a lot when you're trying to write shared APIs around this stuff. So there are certain things that you might be used to when you're just in a pure Kotlin code base that don't work quite as well in the shared context. And so you might find yourself writing a little bit more code in some spots to kind of smooth out the API there. And I kind of liken that to what it was like when we were all first moving from Java to Kotlin. And there was all this extra, like by default, the interop was pretty good, but there was all this extra stuff that you could do to make the Java interop look a little smoother, look a little more kind of Java idiomatic. We're in kind of like an early phase of that, I think, with Kotlin and Swift interop, where like it'd be nice if we had an equivalent of the JVM overload annotation so that this would happen automatically and things like that. But the general lesson is like, don't be afraid to tweak your Kotlin APIs a little bit to make them a little nicer on the Swift side, even if that means writing some code that you wouldn't have had to write otherwise. Yeah, so I'm not going to go through every little possible detail of how those things translate, but so you might have noticed as we were doing that, like there's kind of different rough equivalents of how like what translates from Kotlin through Objective-C to Swift. So there's a nice documentation on the Kotlin Link site of the details of that. But just be aware that there are some subtle differences, such as that default parameter issue and things like that that come up. One of the big ones that you'll almost certainly run into as you're trying to port code that you're used to working on Kotlin or used to working with in Android Kotlin is generics. So suppose we have this box class. It takes a generic argument for the type of contents that it holds. And we want to create a box in Swift. So ideally, it would look as simple as this. And in a lot of cases, it will. In this particular case, it won't, because as that box translates from Objective-C, it needs to be a class type in Swift, which Swift string is not, but Objective-C's NS string is. So you get, or sorry, Swift string is not, so you get this error. Generic class box requires that Swift be flag type. And so you have to kind of do this manual cast here to work around that. Like a little ugly, you can deal with that. But so now let's try to read the contents out of the box. So we have we're going to define this contents. We've cast that input to an NS string, so it must be an NS string when we pull it out, right? But again, we see an error, and it turns out when the generic argument kind of bridges through Objective-C, it the generic lives at the class level, but each of the kind of use sites don't know exactly what type was bound to that generic. And what that ends up meaning is when you, like the T in box T is strictly speaking nullable. It has a nullable any upper bound by default. So when Objective-C is reading out contents, it doesn't know that T has been bound to a non-null string. It thinks it might still be nullable. So you work around that by giving your generics a fixed any upper bound, and that's a pretty useful trick in most of the time when you're working with generics and Swift interop. You might sometimes you want to be able to put nullable things in there. I usually recommend having like a nullable box as well as your box, so that your non-null cases don't get kind of spoiled by this extra nullability that doesn't need to be there. Other kind of unfortunate thing is Objective-C protocols, which is the interface equivalent, don't know anything about generics. So if you try to do the same thing with an interface, you define an interface box, and then try to implement that in Swift, the generic actually gets completely erased, and contents is just a nullable any or an optional any in Swift. So when you're it's like often architecturally we would prefer things to be interfaces where possible, but there are cases where when you're thinking about this interop layer, where having a class at the interop boundary can be really useful because it lets you pass that generic through. And we'll see an example of that later. Another kind of important piece of the interop story is concurrency. I mean, I'm not going to go into detail here. You can do entire talks on this. Kevin has. But essentially, Kotlin Native has this, essentially has needed to implement its own memory management, because Kotlin as a language is written with JVM garbage collection in mind, and that doesn't exist. Like by default on iOS in the Swift environment. So it needs to it basically needs to kind of implement its own reference counting and connect that to what Swift does natively. And in order to kind of make that work efficiently, the Kotlin team opted to have this either shared or mutable model, where if you have mutable state, it's not allowed to cross. It's difficult or not allowed to cross between threads. But you can call this freeze API that will force it via a runtime check to be immutable, and then you can share it across threads. And this is like you can make this work, but it can be very frustrating to use when you're used to how things work on Android and on JVM. And so it's gotten a lot of pushback from the community, and the Kotlin team has been, for the last year and change, working on a kind of new memory model to deal with all of these concerns. So if you're kind of just jumping into this stuff, like it's a good thing to know. It's not going to be super important another year or so down the road, hopefully. And if you want to try out the new stuff right now, there is a preview available in the Kotlin 1.6 M1 release, which just came out last Friday. So JetBrains is very interested in getting feedback on how that's working for people, on where there might be issues. It's not very well optimized yet. Like, I wouldn't go anywhere near using this in production, but it's like the time to try it out if you care about the details of these things and give them feedback. So you can find the blog post announcement at that link, which also has information about how to use it and where to get feedback and stuff. So that was a bunch on kind of how Kotlin bridges to Swift. Now I want to talk a little bit about kind of the different ways that Swift and Kotlin developers tend to write their applications, which we heard a little bit about earlier in the day as well. So one of the first and most obvious ones is like in Kotlin, if you have a piece of data, like say an item in a to-do list, you're going to use a data class for it, and that's going to generate these nice equals and hash root and toString methods, giving you like your easy value quality checks, and your copy methods to be able to kind of mutate it without the class itself needing to be mutable. Swift, on the other hand, is going to use a struct, which is just a pure value type in and of itself. So it can it will create a new copy of itself when you pass it to another variable or when you mutate things. So these are very similar use cases, and even reasonably similar kind of syntaxes and usages, but they're not doing the same thing under the hood. And so if you're a Swift developer and someone like a Kotlin, their shared Kotlin code is passing you a data class, it's going to feel very unnatural to use compared to the struct that you might have written otherwise. And that can be a bit of frustration when you're the iOS team that's developing this app. Luckily, at least in this case, it's not too complicated to kind of create adapters. So you can create extensions on the Kotlin type and the Swift type to kind of build one from the other. And that can be a really nice thing to do at your interop points, at your interop boundary, so that when you're away from that boundary, it just like you're not dependent on the Kotlin type, and so things aren't things feel more like natural Swift. Similar place where this comes up is scaled classes in Kotlin versus enums in Swift. So Swift enums have this associated value construct that lets them essentially have functionality very similar to what we have with scaled classes in Kotlin. So I might have a Kotlin result with a success or failure, or this Swift result going in the same way. And in Swift, you get all you get some nice syntax for pulling the value out of these enums, and you get the exhaustiveness checks automatically. But if you try to do this same handle result method from the Kotlin one, you're forced to add this extra default branch because Swift doesn't know that this is exhausted, even though Kotlin does. And you also you don't get the clean syntax for pulling the value out of it. You would have to, I don't show it on the slide, but you'd have to cast your result to the success or failure. So this is another case where you could probably work around it with extensions in similar ways. It gets particularly complicated for this example because of the generic. It's kind of messy messy or very difficult to pass that generic through in a type safe way. But you can typically cast around it if you need to. But it's just another example of where you might want to add some extra APIs at the interop boundary to smooth that out for your Swift developers. Then another place where Swift and Kotlin do things differently, though they're starting to converge a little bit, is around asynchrony. So Kotlin has its coroutines APIs with suspend functions and flows. So you often have something like a repository class that's going to expose a flow of some data, and then the higher levels of your application can subscribe to that flow. And all of the operators that work on flow are generally they generally use suspending lambdas, so Swift can consume some suspend APIs. So they essentially generate an equivalent method on iOS that has a completion parameter that you can pass that makes it work like a callback, but you don't get any of the other Kotlin X coroutines niceties like coroutine scopes and cancellations by default. But with some work, you can kind of create them for yourself. And it gets a little bit messy, so buckle up a little bit. We're gonna write a adapter around our flow. And what that helps us with is flow is an interface in Kotlin, so it would lose the generic when you try to talk to it from Objective-C in Swift. But if we create this extra kind of class layer around it, the class knows what the generic type is, and that does translate. So you can give it a subscribe method where you pass in just callback lambdas, and those we've already seen translate naturally between Kotlin and Swift. And then inside of that subscribe method, we're doing the passing it to two different flow operators and then calling collect. And then we can kind of wrap that in a repository adapter that it has its own coroutine scope and exposes the data as a flow adapter instead of as a flow. That then lets us, so we then have utility on the iOS side to take that flow adapter and convert it to a publisher, which is the Swift Combine async type. And then at last we can create kind of the iOS equivalent of repository, which just has data as a Combine publisher. So it's it's delegating to the Kotlin, and it's like using that using that Kotlin data as its source of truth. But the external API of it is just what you would naturally get from Swift. That was just kind of a quick run through of it. If you're really interested in the details of this use case, I have a couple of blog posts where I talk about it, as well as a repository of with kind of code samples and Swift side unit tests, so you can actually like play around with it and make tweaks and see how you want to make it work for you if you're interested. And there's also some people who have started to experiment with doing kind of code gen for some of these patterns, which is also something I'm looking to dig into some, but I don't have anything published there yet. So we're in time. I'll do this. Just as a kind of an interesting example of all this stuff, I want to talk about kind of one case study of a app I was working on where we had to do just some interesting kind of funky interop things. Was working with a client who had a very complicated web app, and they wanted to port parts of it to mobile. It was complicated. It ended up kind of running some bits in native UI and some bits in web views, and we had to have all these communication pathways like in and out of the web views, which meant lots of platform-specific wiring to make that work. But we wanted to share some of the kind of core logic at the edges of that were like the core logic of like what was happening in the business logic code outside of the extra stuff that you needed to wire it all together. So that one part of that took the form of kind of shared JSON parsing and parsing logic that was written in Kotlin multi-platform that would then be kind of passed, like stringified and then passed into the web views, who would then kind of respond to it using the existing kind of web setup. So I've changed all the names to protect the innocent, but we had essentially this message dispatcher class in Common that could take in a JSON object message. So this would be like, it would come out of the web view as a string. It would get parsed by Kotlin serialization. And then the shared code would do all its processing of it. It might return a response that would then go back to the web view, but it didn't have to, so that was nullable. This is convenient to work with from Kotlin. Kotlin knows what a JSON object is, but it's kind of unnatural from Swift. What we ended up being able to do is we added these converting utilities between JSON object and NS dictionary. So NS dictionary is the Objective-C type that corresponds to a Swift map, essentially, which they usually call dictionary. With those interop helpers, we could add this extra kind of overload of handle that took a dictionary instead of a JSON object, just on the iOS side. And then in the iOS code, we could just pass it we just pass it like the NS dictionary directly from Swift with whatever data it needed. So that was a whole bunch of kind of random examples and thoughts. What are some of the lessons that come out of this? So one of the important ones, of course, is Swift and Kotlin are different languages. Like they look similar. They grew up in a similar kind of environment and learned a lot of the same lessons. And they look very similar syntactically as a result. But they make some different choices under the hood that sometimes just makes the interop non-trivial. And you shouldn't expect it to be perfect every time, and that's okay. Like having a little bit of extra code you have to write at the interop layer is a lot better than writing all of your internal logic stuff twice. And I again think there's a nice analogy to like how we do extra stuff to our Kotlin when we're writing for Java consumers. You can think about that for your Swift and Objective-C consumers as well. Like definitely consider the pattern of using adapter classes and functions to smooth out that interop layer. like this gives you a little bit of like there's runtime cost to that, obviously. Like you're adding an extra wrapper class, you have to instantiate that and call into it and all that stuff. But it makes your application logic much easier to follow once you're kind of away from that, which I think is a big advantage. Still, though, don't be too afraid to implement things per platform when needed, and I'm going to do any examples of that. But like Kotlin is the Kotlin multi-platform is a wonderfully flexible framework for doing all of this stuff, and you should leverage that. You shouldn't feel like you have to make everything 100% shared. Like, share the things that make sense. If it's complicated to share something, it's okay to write a little bit of it twice. Like, create the abstractions that make sense and that like give you a lot of leverage, but it doesn't have to be everything. And there's definitely lots of opportunity for like code gen and other bits of tooling. As this whole ecosystem matures, we're going to start to see more and more of that. So like Kotlin symbol processing, the new kind of KAPT replacement is just reached 1.0, and it works in multi-platform. So I think we're about to start seeing a lot of the things that you would traditionally use annotation processing for in like in Android projects and in JVM Kotlin are going to start getting unlocked in Kotlin multi-platform. So there's a lot of opportunity. If people are like looking for interesting open source projects to try out, I think there's lots of room in there. And as well, so Kotlin has compiler plugin APIs that aren't stable yet, but they are stabilizing, and people are starting to build things with those too. So lots of interesting things on the horizon. So overall, like I really think like there are complications to doing shared code at scale, but I really think the benefits outweigh them, and I think it's a really exciting kind of time to be involved with all of this stuff. I think it was Jesse Wilson who said shared code is a superpower, and it's a really empowering thing when you can kind of bring your whole, like instead of having your Android and iOS teams kind of siloed up in their own world, building everything twice, you can kind of bring everyone together, solve problems together, and only need to do it once. So here's a couple links, and I'll throw these slides in the Slack channel so people can grab them all if you have kind of things you want to follow up on. And with that, thank you very much, and I will take questions. And if you have questions later, you can find me in the Slack channel for the talk, or you can find me on Kotlin Lane Slack or on Twitter as Russ H. Wolf.
Awesome. Thank you, sir. We have a handful of questions. I'll read them out so that you don't have to try and track them down.
That's exciting.
Yeah. Better than
I do not have Slack up right now.
Lauren asked, so I'll read her whole one. She's got a few levels to it. You mentioned platform-specific interfaces. Can Kotlin multi-platform do structs? And if so, how does that work on Android? I guess let's tackle them one at a time.
Yeah. So yeah, the short answer is no. So like I sort of went into that example a little bit. Like you can create converters to translate your structs into or translate your data classes into structs, for example. But Kotlin as a language does not have value types, and so and it doesn't interop with Swift directly anyway, and so you don't get structs for free. But you can do a little bit of work to get to them, and that's very much something that I think will be solved by CodeGen in the future.
Let's see. Following on to that, what kind of iOS framework does multi-platform build? Does it work well with the Swift package manager?
Yeah. So I didn't go into packaging. I thought about it, but there was enough other stuff going on. So the like by default, it creates just like a framework that you can package however you want. There's a first party plugin to do CocoaPods. So if you want to do if you want your Kotlin framework to be a pod, you can like it generates a pod spec for you and point to the Kotlin that way and all that. And there's a third party thing that does Swift Package Manager. So like Kotlin can export a XC framework and then you can do build a SPM wrapper around it. We're mostly at TouchLab, we're mostly doing CocoaPods these days, but as the community starts to do more as a package manager, we'll probably start to reevaluate that, but we're not there yet. We're mostly doing CocoaPods still for
now. Because multi-platform goes from Kotlin to Swift through Objective-C, is it difficult to debug issues from an iOS app?
Yeah, that's another one that I thought about going into and cut for time. But so there's yes and no. There's there's tooling to debug in the Kotlin native code. So JetBrains puts out the Kotlin multi-platform mobile plugin for Android Studio, which lets you debug your iOS apps from Android Studio. And then TouchLab, we have an Xcode Kotlin debugger, so you can you can be in Xcode, add your Kotlin sources to your Xcode project, and then set breakpoints in there. So it's not quite as smooth as you would have in a single language, just because not everything under the hood translates super cleanly. But it is possible and it's usable.
Cool. And then you mentioned
that's a standard part of our setup, typically.
And you mentioned breakpoints briefly a second ago. Do the iOS and Android breakpoints work across multi-platform?
Yeah. So on the Android side, it's doing the exact same thing it would be doing if you weren't using multi-platform. So yeah, I didn't really emphasize that, but that's the superpower of the Android side is you're talking to different libraries usually, because you have to your common code has to talk to libraries that are multi-platform aware. But otherwise, you're running through essentially the same build process that you would be normally if your shared code was just some other Kotlin library. And then on the sorry, I'm losing the train of the question. But yeah, on the iOS side, I think I covered that from the debugging. Yes.
Cool. We got two more. What does multi-platform pass to Swift when you get when multi-platform gives you data access? Or I'm sorry, it gives you a data class.
So it passes that class, and so it can look a little bit funky from Swift. So it'll have the copy method, for example, even though that's it's pretty awkward to use from Swift because you don't have the default parameter values. So it's usable, but it's not necessarily the thing that a Swift developer would naturally write. And so that's where translating that to a struct can be convenient, or can be a nice kind of way to smooth things out for the Swift developers.
All right, our last question, unless anyone swoops in while I'm reading it. Have you heard anything about looking at going straight to Swift interop from Kotlin in the future? I know it wouldn't be easy, but a lot of the wrapper stuff would be a lot easier. That's from Ellen.
Yeah, it's so it's in their long-term roadmap. It's not in their short-term roadmap. So I think it'll happen eventually. But it also kind of brings all of there's a bunch of other complexities to that too. There's some question of what does that look like for libraries if they have to kind of deal with both of those worlds. There's some question of if most of the generics issues from Objective-C you can cast around in Swift, but it's not clear if you were talking to Swift directly if you'd be able to cast around things in the same way. So there's and there's still just the fact that Swift on direct Swift interop is not going to give you value classes until Kotlin has value classes in the language itself. So it's not going to solve every problem. It'll solve some problems.
All right, we got one more from Lauren, and then we will let everyone get on with their evenings, days, afternoons. When you talk about writing interops, where are you putting those? Is it in the Swift framework Kotlin multi-platform is wrapping into, or does it have to be duplicated everywhere you use the multi-platform framework?
So it gets a little bit complicated when it's stuff on the Kotlin side. like it's easy. It can live just in the common code or in the in like the iOS source of the shared library. When it's Swift stuff, it can be it's not always trivial to kind of package that together as a library because it needs to be aware of the Kotlin library that your application is generating. So there's things you can do with CodeGen where you add an import manually after the fact that points to the Kotlin code directly. It can be a bit of a messy thing to finagle.